my channel. My name is PrachiSharma and this channel is about learning chemistry for 10th grade ICSE. So if you're a student struggling with the revision of the syllabus or practicing questions, or you're not able to understand the concepts, this is the right stop for you. So let's start with today's session. Today's session is about the mind mapping of nitric acid. So as I told you before, what is a mind map? Mind mapping is a consolidated way of revising a particular chapter, focusing on the major important equations, important concepts, and during the examination not going through the entire chapter but focusing on the important portion and retaining that information. So without wasting any more time, let's get started with the mind map of nitric acid. Alright students, so I hope the screen is clearly visible to you. So if you look here, this is how a mind map works. So you have all the different sections with some information in that. For nitric acid, again similar to sulfuric acid, we have the basic properties, the tests, whatever information that you need for nitric acid in one slide right here. And the other one is right here. This is your Oswald process, that is the manufacturing of nitric acid at industrial level. So these are the two slides. In this only you have 4 portions covered, and in the previous one you have about 5 portions covered. I mean just one is left out, others are covered. Okay, so let's get started with this one. I'll be zooming in at every section and we'll be discussing the important portion on that. You can also take out a printout of this, these two, and you can stick it in your room. The PDF for this is available in the description box, or if you join the Telegram channel, I post the PDF directly there before the session is uploaded. So you of course get all the notes in your phone directly on the Telegram channel. Plus for any doubts and concerns, you can directly reach out to me there. Okay, let's get started with the nitric acid portion. So this is nitric acid, that is HNO3. This is what the structure looks like. You have one lone pair shared with oxygen and you have a double bond O on the other side. Then you have free state. So it is found in rainwater after lightning. It is available there in traces, not in a very huge amount but in traces. The next is combined. In combined state you get it as chili saltpeter, that is NaNO3. Then you have KNO3, CaNO3 whole twice. So sodium nitrate, potassium nitrate, calcium nitrate. In these forms you get nitric acid in the combined form. Now let's get started with the lab preparation. Lab preparation events, since you can see A written over here. So A, B, C. This is the yellow color of HNO3. So this is your 2-3 portions of lab preparation. Let's start with the first portion. That is your basic equation for the lab preparation of nitric acid. So it can be prepared by using anything. Either you can use potassium nitrate or sodium nitrate, reacting it with concentrated sulfuric acid at a temperature lower than 200 degrees Celsius. You get KHSO4 plus HNO3. How is this gas collected? So the vapors of HNO3 are condensed to a very light yellow liquid, and what happens, you chill it by the receiver. So you have the receiver tilted. I can show you the diagram. So if you see right here, so this is the diagram for the preparation. So if you see, the receiver is tilted and it is being chilled by running water, and this is where you get nitric acid. So the vapors go down right here, they get collected in the receiver, and you have running water that is cold, which will condense it, condense the vapors to nitric acid. Now let's come back. So this is the collection process. Vapors of nitric acid, let it zoom out. Vapors of nitric acid are condensed to a light yellow liquid by chilling the receiver with running cold water. Then pure acid. If we think about pure acid is colorless. Then why is this collected acid yellow in color? That is because of nitrogen dioxide that is present in it. How does nitrogen dioxide reach there? So as the vapors of nitric acid rise up, because of the heat, because you are continuously providing it heat, some of the nitric acid get turned by thermal decomposition, give out NO2, and that NO2 gets combined with the actual acid that is being collected. So the vapors of nitric acid are combined with NO2 vapors and they get collected in the receiving beaker. So that is the reason we have NO2 present in the beaker with HNO3. Then you have the thermal decomposition reaction given. So 4 of HNO3 gives you water plus NO2 plus oxygen, and this NO2 is a reddish brown gas which gives a yellowish color to your nitric acid. Let's move to the next one. What are the precautions to be followed? So the first precaution is that the apparatus has to be glass. Why is that? Because HNO3 is a very strong acid, so it can attack rubber and cork. So the entire apparatus has to be entirely made of glass. The second precaution is the temperature has to be maintained below 200 degrees Celsius, because first of all you are wasting a lot of fuel. You are anyways getting the product required at below 200 degrees Celsius, so why would you increase that? The second is the apparatus can get damaged because the sodium sulfate at higher 200 degrees Celsius, sodium sulfate is formed, that is Na2SO4, and that is a very sticky substance and it can get stuck to the bottom of the flask. It is very difficult to remove it and the apparatus may also break. So that is the reason the apparatus can get damaged. The third is decomposition of HNO3. Since the high temperature is maintained, the vapors of HNO3, in the previous case we studied over here that some of the nitric acid get decomposed to NO2. But if you maintain the temperature higher, it's a high chance that the product that you receive has less nitric acid and NO2 composition increases. Then the third precaution is concentrated HCl is not used. Why is that? Because it's a volatile acid, and along with HNO3 vapors it will also carry HCl vapors. So that is the reason for the preparation of nitric acid you need a non-volatile acid, and sulfuric acid is a non-volatile acid. Okay, let's move to the next portion, that is yellow color of HNO3. So how can we remove that? So we understand why the color is yellow in HNO3 and how we can remove it. We'll discuss that. So the first is that you can pass dry air or carbon dioxide. You can bubble through it. So when you bubble the dry air or carbon dioxide through it, it drives out NO2 from that, and further it gets oxidized to nitric acid. So as you're removing it, it gets oxidized to nitric acid and gets combined in the acid. The second is adding excess of water. So when you keep adding water to it, NO2 is soluble in water, it gets dissolved in water. And this reaction in particular is also known as reverse of the decomposition of nitric acid. So let's read it. Dry air or carbon dioxide is bubbled through it, which drives out NO2 and is further oxidized to nitric acid. Second point, adding excess of water, NO2 dissolves in water. The reaction is the reverse of the decomposition of nitric acid. Okay, let's move to the next one, oxidizing property. This is very important and these three equations are very important. So on oxidation, what happens is that oxidation happens. Why does it happen? First of all, it happens because when you have HNO3 and it gets decomposed to NO2 and water, you get nascent oxygen. This nascent oxygen is responsible for oxidation of any product. So you have nascent oxygen, you can see that in this equation. Oxidation happens due to the presence of nascent oxygen, and then you have the equation HNO3 giving NO2 plus water plus nascent oxygen. Now let's look at the important equations. You have the important equation with carbon, with sulfur and with copper. With copper you have two conditions. The first is cold and dilute nitric acid. The second is concentrated nitric acid. So you understand the overall concept here. Now let's look into the equations. So when HNO3 is reacting with carbon, you will get carbon dioxide, water and nitrogen dioxide. When it is reacting with sulfur, you will get H2SO4, that is sulfuric acid, water and NO2 again. So focus on these things. Remember it in particular by a particular method, that is carbon reacting with nitric acid will give me carbon dioxide, water and NO2. Then when it is reacting with sulfur, it will give me sulfuric acid. Because sulfur is combining with it, it will give me sulfuric acid plus water, and what is left out? NO2 is left out. Now let's look at the copper condition. Now these two equations are important, students. When you have cold and dilute nitric acid, that will end up giving you NO. Okay, that is nitrous oxide. And when you have hot and concentrated, in that case you will get NO2. I'm sorry about that. In that case you will get NO2. So this is the difference between these two equations. Everything else stays the same, and of course the balancing will change. So copper reacting with HNO3 will give you copper nitrate plus water plus NO, nitrous oxide. This is a very important multiple choice question also. When you have concentrated nitric acid, or you can also, this can also be written as hot dilute nitric acid. In this case, copper reacts with HNO3 along with copper nitrate water, you get nitrogen dioxide. Okay, so make sure that you remember this also, that concentrated nitric acid, you instead of this, you can also say hot dilute nitric acid. You can mention that. Now let's move to the next property. Now next you have tests of nitric acid. So there you have two tests that you have to specifically remember. The first is that nitrates other than sodium, potassium, ammonium produce reddish brown fumes of NO2. So that means if you have a metallic nitrate and your thermal decomposition happens, you get metallic oxide, NO2 and oxygen. So you can simply say that if reddish brown fumes are coming out, that means it's a nitrate. Nitrate is present. Okay. The second is the brown ring test. So what is brown ring test? In brown ring test, the step 1 that you have is using freshly prepared iron sulfate. Okay. Then second step is add concentrated H2SO4 from the side. So you have a test tube, and in that you have freshly prepared iron sulfate. You add concentrated sulfuric acid from the side of the test tube. You have to make sure it does not go drop wise, but it's a regular liquid flowing. Okay. You add concentrated sulfuric acid. You cool it. You cool the test tube without stirring it. Okay. You have to be very careful. You don't move it. You cool the test tube. So when the test tube is cooled, a brown ring is formed at the junction of the two liquids. So one part of the liquid will be up, a part of the liquid will be at the bottom, and in the center you will see the brown ring being formed. This brown ring is formed of nitrosoferrous sulfate. So you have to remember this, nitrosoferrous sulfate. What is the name of the brown ring, or what is the compound the brown ring is made up of? That is nitrosoferrous sulfate. So this is your brown ring test. This brown ring justifies the presence of nitrates in that. The next is effects of heat on nitrates. This is pretty simple. Let's look at that. So you have sodium nitrate and potassium nitrate. It gets decomposed on heating. You get NaNO2 plus oxygen. So you get NaNO2 plus oxygen. Oxygen comes out, that's it. All other nitrates except silver and mercury. So these equations are for except silver and mercury. And silver and mercury, I have mentioned it right here. Okay. So pay attention very closely on this. If you have sodium or potassium, you will get a basic compound out, that is NaNO2. Along with that, you will have oxygen coming out. Then except silver and mercury. So 4 exceptions you have to remember. Sodium, potassium separate, silver, mercury separate. Any other nitrate other than that will give you nitrogen dioxide along with oxygen. Okay. So CaNO3 whole twice, that is calcium nitrate, will give you calcium oxide, nitrogen dioxide and oxygen. Same thing, when you have zinc nitrate, you will get ZnO, that is zinc oxide, nitrogen dioxide and oxygen. Same thing will happen for lead. Lead nitrate, you will get lead oxide, nitrogen dioxide and oxygen. Now few things you have to remember here. Calcium nitrate is a colorless crystalline which gives you a white compound, that is calcium oxide. Zinc nitrate is very deliquescent. What is deliquescent? That means high tendency of getting vaporized. And it gives you a yellow colored compound which is yellow when it is hot and it turns into white when it is cooled down. Then when you have lead is a colorless crystalline, nitrate is a colorless crystalline compound which gives you a yellow solid which fuses with glass. Okay, it fuses with glass. Now let's move to the next one. You have copper nitrate. Copper nitrate will give you copper oxide, nitrogen dioxide and oxygen. Okay students. Now let's come on silver and mercury. So silver nitrate will give you Ag only, no oxides. Ag, NO2 plus oxygen. Same thing with mercury nitrate. Mercury nitrate will give you mercury, nitrogen dioxide, oxygen. And the last one is when you have ammonium nitrate. So ammonium nitrate will decompose into N2O. So this is a laughing gas. Instead of giving NO2, you get N2O plus water vapors. So ammonium nitrate decomposes very explosively, leaving no residue. Everything comes out as a gas. You don't get any residue. A part of it turns into laughing gas and a part of it turns into water vapors. So let's look at this once again. This is important portion. So let's look at this once again. If you have sodium and potassium nitrate, you get a compound and oxygen. No NO2. Okay. No nitrogen dioxide. No reddish fumes. So potassium or sodium, you get NaNO2 plus oxygen, or you get KNO2 and plus oxygen. Except silver and mercury, if you have any other metallic nitrate, you get oxide, NO2 plus oxygen. Okay. If you have silver and mercury, you don't get metallic oxide, you directly get NO2 plus oxygen. And if you have ammonium nitrate instead of giving reddish brown gas, it gives laughing gas, that is N2O plus water vapors. And ammonium nitrate decomposes explosively, leaving no residue behind. Okay students, this is it. Let's move to the next portion, that is the Oswald process, that is the manufacturing of nitric acid. So let's start with the step 1. The important portion for the Oswald process is all the equations. Very important. They are specifically mentioned in the latest syllabus. Equations are important. So the first portion that is happening here is dry air is combining with ammonia. So you have dry air plus dry ammonia combining in the ratio of 10:1 by volume. You compress it and move it into the catalytic chamber. Okay. In the catalytic chamber, you have platinum gauze already present and the temperature is brought to 800 degrees Celsius. At this position, oxidation of ammonia happens. Once oxidation of ammonia happens, this reaction is exothermic. So all the gases which are being made are hot. So you move it to a cooling chamber which is known as heat exchanger. After heat exchanger, you add more air to it and move it to the oxidizing chamber. Okay, let's look at it again. Dry air combined with ammonia in the ratio 10:1, compressed, moved to catalytic chamber. In the catalytic chamber, you have platinum gauze at 800 degrees Celsius. Oxidation of ammonia happens here. Since the oxidation of ammonia is an exothermic process, everything gets heated up. So you move all the contents to a heat exchanger. Heat exchanger is a cooling chamber. In this position, you add extra air to it and that you push to the oxidizing chamber. Now let's look at the equation. You have ammonia adding oxygen to it in the presence of platinum at 800 degrees Celsius. You get NO, water and heat. This equation is important at the step 1. Then move to the second step, oxidation of nitric acid in oxidation chamber. So when you reach oxidation chamber, you are actually dealing with NO, water, and you add extra air to it, right? So if you look at this position, when you are adding air to it, what are you adding air to? You are adding air to NO plus water. This is the content that happened after oxidation of ammonia. This is what you are moving to oxidizing chamber. When you add oxygen to NO, you get NO2. So nitric oxide combines with oxygen to form nitrogen dioxide at 50 degrees Celsius. Then you move these contents to step 3. So at step 3 in NO, you will add up more air. Whatever remaining air is there, you add up that. So step 3 is absorption of nitrogen dioxide in water. So you have NO2, you add water and more air to it. That will give you nitric acid. So let's look at that. NO2 plus remaining air, you move that to absorption tower. In absorption tower, you have steel tower with quartz stone. From top, warm water trickles. So in the absorption tower, it's a steel tower with quartz stone on the sides, and you have warm water trickling from the sides. Let's look at the equation. NO2 plus water plus oxygen giving you nitric acid. This nitric acid obtained is 50% of concentration. By further distillation, you can bring it to a 68% of concentration. Let's move to the next one. This is concentration of nitric acid. Okay, so 98% of concentrated nitric acid can be obtained by distilling 68% of nitric acid over concentrated H2SO4. This is 98% is also known as fuming nitric acid. Then the second point is strongly cooling 98% concentrated sulfuric acid. So till what percentage do you cool it down? You cool it down till -42 degrees Celsius. And this is the point where your crystals are formed for nitric acid, and this can bring it down to 100% concentration. Now higher ratio of air is used because oxygen is only 1/5 in air and it is required for all the 3 chambers. So that is the reason we keep adding more air. So you are adding air in the first step also, second step also, and third step also. You keep adding air because you need oxygen, and only 1/5 of oxygen is present in air. Then quartz is acid resistant, and when packed in layers, it helps in dissolving nitrogen dioxide uniformly in water. So if you see in the third step, you see you have quartz, that is steel tower, and you have quartz stone. Why do we need quartz stone? Because it is acid resistant and it helps in dissolving nitrogen dioxide uniformly. Okay, so this is your Oswald process. It was discovered in 1914 by a German chemist, that his name was Oswald. Now let's look at the few diagrams very quickly. So this was the preparation of nitric acid. We already discussed this. And after this you have the Oswald process. So you can clearly see that when you have water trickling down and you have everything right here. So if you have any doubts about the process, you can ask me that in the comment section. And the last is a flow chart. I have also attached a flow chart here. So you can take a look at the flow chart also. Alright my dear students, so this is it for today's session. I hope you understood what mind mapping is, and you also understand how important it is for your revision and understanding of the concepts. I am trying my best to keep the videos short and crisp and give you a lot of more information that is required for your examination. So thank you so much. Make sure that you share this video with your friends and help us move forward. Thank you so much. I hope you have a wonderful day.